Right, so let's unpack this. I want you to picture a scenario. It's Tuesday afternoon.
Just a normal Tuesday.
Right, a normal Tuesday. You or, your IT team decides to deploy a shiny new AI system.
Oh, the shiny new toy.
Yeah.
Everyone loves that day.
Exactly. Maybe it's a co-pilot for your customer service team or like a generative AI workflow for your data analysts. And honestly, the process feels like absolute magic.
It really does. It's incredibly seductive.
It is. You can probably get a proof of concept up and running before you leave the office for dinner.
Easily.
Because the technical capability is just, sitting there in the cloud. It's waiting to be plugged in via an API. You type a prompt, it generates a perfect response, the stakeholders are thrilled, and you just feel like a total genius.
Until the hangover hits.
Yes, the hangover. Because I want you to fast forward 12 months. That same AI system is now deeply embedded in your daily operations.
It's everywhere.
Right. And here is the question that should actually be keeping you awake at night. Can you actually trust the decisions that AI is making a year from now?
That is the million-dollar question right there.
I mean, when the underlying data has drifted, when your corporate policies have completely changed, or, and this is the terrifying part, when a regulator comes knocking.
Oh, yeah, when they ask exactly how a specific decision was reached for a specific customer. Good luck.
Exactly. The hangover after that Tuesday afternoon deployment is just brutal.
It is brutal. And you're describing, really, the fundamental tension of our era. There is this massive gaping canyon between what we call technical capability, how fast you can deploy a frontier model, and institutional readiness.
Institutional readiness.
Right. How well you can actually govern that model over time. I mean, we are seeing companies deploy in days, but then they are failing audits months later.
Because they have no idea what it's actually doing.
Exactly. They have no idea what the system is doing under the hood. They just know it types fast.
Which brings us to the core focus of today's deep dive. We've got our hands on a fascinating 2026 paper by David Berigny.
It's a dense one, but it's brilliant.
It really is. It's titled Governing Hybrid AI for Institutional Resilience. Now, I want to set expectations right away for you listening.
Yeah, quick disclaimer here.
Right. If you are looking for tips on how to build a smarter, faster chatbot or, how to write better prompts, this is not the deep dive for you.
No, you won't find prompt hacks here.
Definitely not. Berigny's paper is a massive, comprehensive blueprint for what he calls an evidence-centric operating model.
And that phrase, operating model, that is the key to unlocking this entire paper.
It really is.
The mission today is to fundamentally shift your mindset. We are desperately trying to move the industry away from the hype of AI as a tool.
Right, like it's just a calculator or something.
Exactly. We need to stop thinking of AI like a calculator or a spell checker that you just, buy, install, and then completely ignore. We have to start understanding AI as a long-lived socio-technical capability.
Socio-technical, so it's not just the math.
Not at all. Today, we are going to unpack how you actually govern autonomous AI agents. We'll get into why just dumping everything into a centralized cloud is a complete recipe for disaster.
Oh, that part is wild.
It is. And we'll talk about why the current trend of hyper-specialization in the tech workforce, like hiring people who only know prompt engineering, is actually destroying our ability to manage AI safely.
Okay, so to understand why Berigny is pushing this massive operating model, we really have to look at the pressure cooker organizations are in right now.
Our pressure is immense.
It is. And I don't want to just rattle off acronyms, but if you look at the major global frameworks hitting the market right now, I mean, the U.S. has NIST's AI risk management framework.
All right.
Europe has the EU AI Act. There are the OECD AI principles. There's the ISO 42001 standard.
It's an alphabet soup of regulation.
It really is. But they are all converging on one unavoidable truth. AI risk is not a math problem.
No.
It is not a technical property of a neural network. It is an organizational property.
That is the crucial shift. It's about how the whole system is built, run, managed, and monitored by human beings.
Like, think about the legal reality of the EU AI Act right now.
Oh, it's intense.
It makes it a binding legal obligation for high-risk systems to have rigorous data governance, technical documentation, logging, transparency, human oversight.
You cannot just hand a regulator the API documentation from your cloud provider.
Right. You can't just say, here is our compliance. They built a safe model.
A regulator does not care. They want to see your operating model.
Exactly. NIST approaches it similarly from this life cycle risk perspective, and ISO 42001 literally demands an artificial intelligence management system.
Much like companies have information security management systems.
Exactly. You cannot buy a secure model and just assume your organization is secure.
Right, because if you don't have an architecture designed to govern the data, the identity of the actors, the evidence, and the infrastructure as an integrated whole, well, you are flying blind.
Okay, so I am sold on the panic.
Good. You should be.
But how do we actually build this structure? We can't just talk in abstract regulatory frameworks. We have to start with the architecture itself.
We do.
And reading through Berigny's paper, the first thing that hits you is this idea that organizations are suffering from a governance deficit.
A massive deficit.
They are obsessing over isolated AI tools. Someone builds a co-pilot over here in HR. Someone else builds a retrieval workflow over there in legal. An autonomous agent gets spun up in supply chain, but there is no underlying foundation connecting them at all.
Berigny calls it the illusion of tooling.
The illusion of tooling.
Yeah. We treat enterprise AI like we were just buying a fleet of word processors. But modern enterprise AI is a complex ecosystem.
It's not just a standalone app.
Exactly. When you ask a modern AI a question, it doesn't just hallucinate an answer from its training data anymore. It uses retrieval pipelines to search your company databases.
Right. It's actually looking things up.
It uses orchestration engines to decide which database to check. It uses agentic delegation to act on your behalf.
It's pulling from cloud services, local servers, everything.
So if your governance team is only evaluating the model itself, just the brain, they are completely ignoring the entire nervous system.
That is such a good way to put it.
To solve this, the paper proposes a highly specific 7-layer architecture. And this is vital. Those layers are bound together by a cross-cutting control plane.
Okay, I love how visual this is in the text. I want to walk through these layers, starting from the absolute bedrock and moving up.
Let's do it.
Let's ground this with a hypothetical example. Imagine I'm an employee asking an internal HR AI system if I have enough accrued leave for a 3-week sabbatical. What is the very bottom layer that this request hits?
At the very bottom, you have the data substrate.
The data substrate.
Right.
Yeah.
This is your raw material. In your HR example, this is the actual SQL database containing employee leave balances. It's the identity stores that know who you are.
So the raw files.
Yes, the raw PDF files of the company sabbatical policy, the telemetry logs, all of it. But crucially, this isn't just a messy data swamp.
Yeah.
The data substrate layer includes the rules for data locality and the lawful handling of that data. It defines where that data physically sits and who legally owns it.
So it's like the filing cabinets, but with locks on them.
Exactly.
Now, sitting right on top of that raw data is layer 2, the evidence fabric.
The evidence fabric, yeah.
We are going to do a massive deep dive into this specific layer in a few minutes because it just completely blew my mind. But give us the brief conceptual overview. What does the fabric do to that raw data?
The evidence fabric is essentially the transformation engine.
Transformation engine.
Right. It takes that raw PDF of the HR policy from the data substrate and turns it into a provenance-rich, policy-bound artifact. It wraps the data in context.
Like tagging it.
More than tagging. It attaches metadata where this policy came from, what version it is, what the confidence level of data is, and what access policy applies to it. It makes the raw data auditable, so the AI knows exactly what it's looking at.
Okay, so we have the raw data substrate and the evidence fabric organizing and tagging it. Layer 3 is the model and task layer.
Yep, layer 3.
I assume this is where the actual AI lives, like the shiny brain.
That's the compute brain. The cloud foundation models, your local open source models running on your own servers, the retrieval augmented generation pipelines.
And notice how deep we are into the stack, and we are only just now hitting the AI model.
Exactly. The model relies entirely on the 2 layers below it to understand its environment. It's not floating in a vacuum.
Right. And moving up, layer 4 is the orchestration layer. Because when you have all these different models and databases, something has to direct traffic.
The traffic cop is a really good way to look at it.
Right.
The orchestration layer handles routing tasks.
So it decides where the question goes.
Yeah. When you ask about your sabbatical, the orchestration layer decides, okay, I need to send the policy question to the language model, but I need to send the leave balance query to a SQL tool.
Oh, I see. It splits it up.
It delegates actions and manages workflow composition. It also handles failover. Right. If your main cloud model crashes while processing your request, the orchestration layer seamlessly routes the task to a backup local model.
That makes total sense. Then layer 5 is the interaction layer. I'm guessing this is the surface area. It's what I, the human employee, actually see.
Yes, the chat window, the analyst workbenches, the API endpoints, it's the interface.
And directly adjacent to what you see is layer 6, the feedback loop.
This is where it gets really interesting.
Yeah, because trustworthy AI cannot exist without ongoing human oversight. This layer handles user contestations, red teaming signals, steward reviews.
Right. If the HR bot tells you that you don't have enough leave, but you know you do, and you click thumbs down, this is incorrect,
Yeah.
that action happens in the feedback loop.
And the vital architectural detail here is that this loop feeds directly back into the evidence fabric.
Yes. Your contestation becomes part of the auditable record of that HR policy.
So the system actually learns from its own audits, doesn't just log the error in a spreadsheet that some IT guy ignores. It alters the evidence.
Exactly. It's a living system.
Finally, layer 7, sitting underneath all of this like a massive concrete foundation slab, is the resilience substrate.
The resilient substrate.
The paper describes this as ensuring workload portability across different environments.
We will definitely dig into this later, but yes, the resilient substrate ensures that this entire stack, the data, the evidence, the models, the orchestrator, can run across public cloud environments, your own on-premises server racks, or even disconnected edge devices.
Okay, I followed all 7 layers. But you mentioned something earlier that I want to challenge you on.
All right, lay it on me.
You called it a cross-cutting control plane. In the architecture diagram in the paper, it's drawn as this vertical side panel that intersects every single one of those 7 horizontal layers.
It intersects all of them.
Right, and it handles identity, authorization, policy evaluation, logging, cryptography. Let me push back here.
Sure.
Isn't this just massive IT bloat? Why do we need a separate vertical system checking every single layer?
Okay, let me ask you this. In your HR example, how does the AI model at layer 3 know that you, the person typing at layer 5, are legally allowed to see the data at layer 1?
I mean, I guess I assumed it just, knew
Yeah.
because I logged in.
That assumption is exactly how massive data breaches happen.
Oh, well then.
You log into the chat window, but the chat window is just layer 5. The chat window talks to the orchestrator. The orchestrator talks to the model. The model talks to the evidence fabric. The evidence fabric pulls from the substrate.
That is a lot of hops.
It is. If you don't have a centralized control plane intersecting every single layer, you have to build identity and security protocols into every single one of those connection points manually.
Which would be a nightmare.
A total nightmare. The control plane is a unified enforcement mechanism. When you log in, the control plane tracks your identity token down through every single layer. It ensures that at no point does a highly capable AI model accidentally pull the CEO's salary data to answer your question about a sabbatical.
Okay, I have an analogy for this because I want to make sure the listener really internalizes why this architecture is mandatory.
I love a good analogy.
Deploying a massive, powerful frontier model from the cloud without these 7 layers and that vertical control plane is like buying a state-of-the-art Formula One engine and bolting it to a golf cart.
A golf cart with absolutely no seatbelts.
Exactly. You have the raw power, the engine is incredible, it can process information at blinding speeds.
Right.
But without the transmission to route the power, which is your orchestration layer, without the steering to direct it, your evidence fabric, without the brakes to stop it, your feedback loop,
Yep.
and without the telemetry dashboard telling you if it's overheating your control plane, you are just going to crash the golf cart into a brick wall.
You literally cannot control the power you have purchased.
And returning to the regulatory landscape we talked about, crashing that golf cart has severe legal consequences now.
Very severe.
If you don't have a feedback loop tied to an evidence fabric, if you don't have a control plane tracking authorization across the stack, you cannot comply with emerging laws.
When the auditor asks how the AI made a decision, you can't just hand them the F1 engine and say, look how fast it is.
Right. They want to see the steering column.
Exactly.
So we have the highway built, we have the transmission and the steering. But what is the actual cargo traveling on this highway?
The cargo.
Right. What is the AI actually producing that we can track? Because we aren't just talking about chatbots anymore.
No, we are far beyond simple chatbots.
This brings us to what I think is the most conceptually fascinating part of the paper, the evidence fabric, and specifically this concept of an evidence object.
The evidence object is the true governance hinge of the entire system.
The governance hinge.
Yes. Without this, the architecture falls apart completely. Berigny defines an evidence object as a machine and human-readable artifact that binds an AI output to its source evidence, its provenance, the retrieval parameters, the policy context, the authorization context, and its review history.
Okay, that is a very dense definition.
It's a mouthful.
Let's slow that down and trace the life cycle of one of these objects, because this fundamentally changes how you think about AI outputs.
It really does.
Instead of an AI just spitting out a paragraph of text that you copy and paste into an email, it is basically constructing a digital dossier. Walk us through how an evidence object is actually born.
Okay, it starts at the raw source, down in the data substrate. Let's say you have a massive corpus of internal company transcripts, policy documents, and telemetry logs.
Okay.
The first step the system takes is parsing and segmenting that raw data into addressable chunks. And here's where it gets really interesting, because segmentation is usually treated as a purely technical back-end engineering task.
Right. You just cut a PDF into paragraphs so the AI can digest it, right?
That's what people think. But Berigny argues that segmentation is actually the first major governance decision.
Wait, really? Why is cutting a PDF into paragraphs a governance decision? Isn't it just formatting?
Think about the mechanics of retrieval. What you include and what you exclude at the segmentation stage determines exactly what the AI can later retrieve, cite, and use to make decisions.
Oh, I see.
Let's say you have a 50-page client contract. If your segmentation algorithm arbitrarily cuts the document right in the middle of a liability clause, separating the condition from the penalty, well, the AI might later retrieve only the penalty, completely missing the context of the condition.
That would be a disaster in a legal setting.
A total disaster. Or, if you segment a document poorly and accidentally include a paragraph containing sensitive personal data that shouldn't be there, the AI will retrieve it and use it in an output.
Because it doesn't know any better.
Right. Segmentation dictates reality for the model, so it has to happen under strict policy constraints.
Ah, I see. The boundaries you draw around the data dictate what the AI thinks is a complete thought. So you carefully chunk it up under policy. Then what?
Then comes the binding phase. This is where the evidence object truly takes shape. You take that carefully extracted chunk of text and you permanently attach metadata to it.
Like putting a wax seal on a document.
That's a great way to put it. You attach the original document identifier, the version number, the specific search parameters the AI used to find it, a statistical confidence score, the data rights associated with it, and a timestamp.
That is a lot of baggage for one paragraph of text.
It is.
Yeah.
But all of this provenance metadata travels with the object everywhere it goes within the system. It becomes self-describing.
So if that piece of data gets exported by the AI into a summary brief for another department, all of that context goes with it.
Exactly.
It's not just a stray fact floating in a paragraph. It's a fact with a passport and a history.
And the next stage in the life cycle is the steward review. This is where human judgment explicitly enters the loop. And the term steward is used deliberately here.
It sounds very formal.
It is. We are not talking about a tired employee just clicking approve on a massive queue of automated tasks without looking. A steward is a human expert who validates, challenges, or annotates the evidence based on real-world context.
Like, give me an example.
Sure. If the AI retrieved a chunk of policy that is technically accurate but practically outdated due to an unwritten company shift, the steward flags it.
Okay, I have to jump in here and play devil's advocate for the listener.
Go for it.
Because when I hear this entire process, carefully segmenting data under policy, binding massive amounts of metadata, having human stewards review evidence objects before they become approved outputs, my first thought is, doesn't this slow business down to an absolute crawl?
It sounds very bureaucratic, yes.
Right. I mean, the whole promise of the generative AI revolution was instant answers, massive scale, and replacing tedious human review. If every single AI summary needs this massive digital paper trail attached to it, aren't we just reinventing bureaucracy but making it digital?
It is a very fair pushback, and it's the exact tension every chief information officer is wrestling with right now. Speed versus safety.
Yeah.
But you have to understand the why behind this rigor. We are moving away from AI as a black box productivity layer.
Okay.
If you are using AI to write a polite email to a vendor, sure, you don't need an evidence object, but we are moving toward AI as a decision intelligence system.
Decision intelligence.
Right. When the stakes are high, When an AI is recommending a medical treatment plan in a hospital, or approving a multi-million-dollar commercial loan, or analyzing defense logistics in those domains, the AI's final text output is just one minor artifact.
Really? Just a minor artifact.
Yes, the evidence actually becomes the product.
The evidence becomes the product. Wow, that is a massive conceptual shift. You aren't buying the summary, you're buying the proof.
Exactly. Because a year from now, if that commercial loan defaults, or if that medical treatment fails, no regulator, auditor, or judge is going to accept the AI told us it was a good idea as a legal defense.
They would laugh you out of the room.
They absolutely would. You need to be able to pull up the exact decision and answer definitively what specific documents were used to make this recommendation, by whom, under what policy, what exact version of the model was running on that specific Tuesday.
And without the evidence object, you just don't know.
You simply cannot answer those questions. The digital paper trail isn't bureaucracy. It is the mechanism that makes the incredible speed of AI actually safe to deploy at enterprise scale.
And I imagine this connects directly back to that feedback loop layer we talked about in the architecture earlier.
Deeply. Let's say an AI generates an output, an evidence object is formed, it informs a decision. But 6 months later, a human user realizes the AI fundamentally misunderstood a subtle nuance in a legal precedent.
Okay.
They contest the output. In a normal, poorly governed system, that contestation just disappears into the ether. Maybe an IT ticket is filed and forgotten. The AI keeps making the exact same mistake.
Right, it doesn't learn from a help desk ticket.
But in an evidence-centric operating model, that contestation becomes a permanent part of the evidence object's provenance.
So the system actually remembers its mistakes on a molecular level. The data itself carries the skull of the error.
Yes, it allows the system to continuously apply drift fixes. The retrieval pipeline actually gets smarter because the evidence corpus itself is constantly being refined, annotated, and corrected by human feedback.
That's incredible.
It is. This is exactly how you operationalize the requirement in ISO 42001 for continual improvement of the AI management system. It is not a yearly audit where consultants come in with clipboards. It is a living, breathing feedback loop bound directly to the data.
So we have these perfectly tracked, deeply governed evidence objects. We know exactly what data is being used, how it was chunked, and who reviewed it.
Yep.
But here is where the narrative of the paper takes a really sharp turn, because increasingly, the entity doing the retrieving, the summarizing, and the decision-making isn't a human typing into a chat interface.
No, it's not.
It is an AI agent operating entirely autonomously in the background. And those agents, as Berigny argues, need a driver's license.
This is perhaps one of the most urgent security and governance challenges we face right now. The paper states unequivocally that autonomous agents can no longer be treated as anonymous background service accounts.
Like how we usually do in IT.
Right. In traditional IT architecture, you might have a generic service account that runs a database backup script every night at 2 a.m. It has a password, it wakes up, it runs its single script, it goes back to sleep.
Pretty harmless.
You absolutely cannot treat a generative AI agent like a dumb backup script.
Yeah.
They are making complex, non-deterministic decisions. They must be first-class governed subjects.
The paper introduces governed agentic non-human identities, or NHIs.
NHIs, yes.
And it actually provides a formal mathematical tuple, a definition for what an NHI must be. It defines it as this string of attributes: ID, sponsor, auth, cred, tools, mem, poll, log, state.
It's a very elegant formalization.
Now, as someone who breaks out in a cold sweat when I see math, can we translate this? We can't just list these out. What do these actually mean in practice for an AI agent?
Let's break down the critical ones, because this is how you actually control an agent. The ID is simple. It's the unique identifier, the agent's name tag.
Okay, easy enough.
But the very next attribute, sponsor, is arguably the most important word in the entire paper.
Sponsor.
Every single non-human identity must have an accountable human or organizational owner. Full stop. The sponsor is the entity that takes legal and operational responsibility for what the agent does.
So if my autonomous agent makes a disastrous financial trade that costs the company millions, the
That's
company doesn't blame the agent. They come looking for me, the sponsor.
Precisely. This maps directly to the EU AI Act's requirement that accountability for high-risk systems must be traceable to identifiable natural or legal persons. An agent never acts on its own behalf. It acts on behalf of its sponsor.
Okay, so how does that authority actually get passed down? Because if I am the sponsor, I am not sitting there clicking approve on every single microscopic action the agent takes, right?
No, of course not.
Because that totally defeats the purpose of having an autonomous agent in the first place.
This is where we get into the mechanics of auth and cred authorization and credentials through a process called delegation.
Delegation.
The architecture relies heavily on established identity standards, specifically OAuth token exchange semantics. Have you ever logged into a new website by clicking Continue with Google?
Sure, all the time. It's so much easier than making a new password.
That is OAuth in action. It allows you to grant a third-party application limited access to your Google account without giving them your actual password. Berigi applies this exact mechanism to AI agents.
Oh, wow.
In the oath framework, there is a concept of a subject token and an actor token.
Okay.
The subject token identifies the party on behalf of whom the request is made, that is you, the sponsor. The actor token identifies the acting party, the AI agent itself.
So when the agent goes to open a database, it essentially hands the bouncer at the door two IDs. One says, I am Agent X, and the other says, I am acting on the strict authority of human Y.
Exactly.
So the system always knows both who is doing the action and for whom they're doing it.
Exactly. And the agent acts under incredibly bounded scopes. It doesn't get root access to the whole network just because you are a manager.
Right.
It gets a delegated token that says, you are allowed to read these 3 specific files and execute this one specific tool on behalf of this specific human, and this permission expires in exactly 2 hours.
That is super locked down.
It has to be. Furthermore, to make this trust portable, say, if your enterprise agent needs to leave your network to interact with a government API, the model uses W3C verifiable credentials and decentralized identifiers, or DDs.
Okay, explain DADs because that sounds like blockchain jargon.
It's just a way to prove something is true without relying on a central authority. Think of a physical driver's license. The government issues it, you hold it in your wallet, and you can show it to a bartender to prove your age.
And the bartender trusts the government seal.
Right. The bartender trusts the cryptographic seal of the government without having to call the DMV. A verifiable credential works the same way for an AI agent.
That makes sense.
It carries a cryptographically signed credential, proving it is authorized by your company, and it can present that to external systems to negotiate access.
I have another analogy for this whole delegation process.
Let's hear it.
It's like giving a corporate credit card to an intern.
Oh, scary.
Right. You don't just hand an intern a blank check and say, go buy whatever the company needs. You set a very specific spending limit. You restrict the card, so it only works at specific vendors, like office supplies are approved. But if they try to swipe it at a Ferrari dealership, the transaction is blocked.
Hopefully.
And you carefully monitor the receipts. We have to do the exact same thing for AI agents. We give them a bounded token, not a blank check.
That captures the mechanics perfectly. And just like that intern, the agent has a life cycle.
Yeah.
It's not just a piece of software you turn on or off. The paper outlines a specific lifecycle management process for agents. You provision them, authorize them, activate them, monitor them, rotate their credentials, suspend them if they act weird, and finally, retire them.
Let's talk about that last step, retire, because you mentioned the mem attribute earlier, memory.
Yes, memory.
The paper highlights a crucial detail here about retiring memory that completely blew my mind. When you retire an AI agent, it's not like deleting a traditional user account.
No, it is a massive shift in how we must think about software life cycles. Traditional software doesn't really have memory in the human sense.
Right.
It has transactional logs and state data, but it doesn't build a contextual, semantic understanding of the organization over time.
But AI agents do.
AI agents do. If you have an agent that operates for a year, assisting an executive with emails, drafting strategy documents, and listening in on meetings, it accumulates a vast amount of operational memory.
It learns everything.
It learns the executive's preferences. It absorbs highly sensitive context from thousands of private conversations. It infers internal company politics and unreleased strategy.
It essentially becomes the ultimate corporate insider. It knows everything.
Yes, and that operational memory becomes a massive, glowing risk surface.
A risk surface.
If you decide to retire that agent and you just revoke its password but leave its raw memory state sitting on a server somewhere, that is a goldmine for an attacker.
Or just a massive privacy violation waiting to happen if another employee accidentally accesses it.
Exactly. The paper argues that retiring an agent means securely destroying its memory state. Memory is an explicit field in that formal tuple we discussed because it must be governable.
It has to be controlled.
It must be versioned, bounded, and subject to strict deletion protocols, just like a highly classified document corpus.
So we have meticulously tracked data through evidence objects. We have closely monitored, bounded AI agents acting under strict delegation. But what happens if the actual physical environment they operate in breaks? Where does all this massive infrastructure actually run?
The infrastructure.
That takes us to the next major concept in the paper, the brittle cloud and the hybrid AI imperative.
This is where Berigny directly challenges the dominant narrative of the tech industry.
He really goes after it.
He does. For the past decade, the answer to literally every enterprise IT question has been, move it to the cloud. Just centralize everything in AWS Azure or Google Cloud.
Right, it's what everyone says.
But as AI becomes mission-critical infrastructure, as it becomes, the actual brain of the organization relying purely on the centralized cloud is strategically brittle.
Why is it brittle? The cloud is supposed to be infinitely scalable.
Scalability is not resilience.
Okay, explain that.
If your entire organizational intelligence relies on a single, continuous API connection to a massive cloud provider, what happens when that provider has a catastrophic outage?
You're in trouble.
What happens if someone with a backhoe accidentally severs the fiber optic cable leading to your office? Or what if geopolitical tensions suddenly sever your connection to servers in another country?
Or what if privacy laws change overnight and you can no longer legally send your data to that provider?
You're paralyzed.
The brain of your company is suddenly unreachable. You can't even open a document because the agent that retrieves it is offline.
Precisely. The natural endpoint for secure enterprise AI is a hybrid deployment architecture. You maintain the centralized control plane, that vertical side panel we discussed earlier, handling identity, policy, and logging, but you distribute the actual execution of the AI workloads across 3 distinct environments:
Which are?
the cloud, on-premises, and the edge.
Let's unpack the strategic value of each of those 3 environments because it's not immediately obvious why we want to manage hardware again. Why do we need all of them?
The cloud is obviously your heavy hitter.
Right.
It is great for massive scale. It offers elastic compute power and, most importantly, access to the absolute frontier models, the massive trillion-parameter giants that you couldn't possibly afford to run in your own basement. But it has liabilities.
Like what?
Data movement costs, sovereignty issues, and utter dependence on external internet connectivity.
Right. So where does on-premises fit in? Why go back to buying server racks?
On-premises, or what the industry sometimes calls sovereign racks, are legally and operationally required for strict data sovereignty.
Okay.
If you are a hospital dealing with highly regulated health records or a defense contractor handling classified schematics, you cannot legally or safely send that data out to a public cloud API.
And have to stay in-house.
It must be processed locally on hardware you physically control. It also serves as a massive buffer against cloud outages.
And the edge. When we say edge, we are talking about local sensors, mobile devices, IoT equipment on a factory floor.
Exactly. Edge execution is crucial for latency-sensitive tasks. If an AI system is controlling a robotic arm on a high-speed manufacturing line, relying on a 200-millisecond round-trip delay to a cloud server in another state is unacceptable.
The arm will crash.
The decision must be made locally on the machine. Furthermore, the edge provides true survivability when completely disconnected. If a cargo ship at sea loses satellite connection, its local navigation and logistics AI systems must continue to function autonomously.
To bring this to life, the paper walks through 3 specific operational modes for this hybrid setup, showing how failover works mechanically in practice.
This is where the resilience really shines.
Let's trace a workload through these modes. Mode 1 is normal conditions.
In normal mode, the cloud is your primary engine for heavy lifting. Your on-premises infrastructure is sitting there as a warm standby.
A warm standby.
Right. It's continuously syncing data, evidence, objects, and policies from the cloud. But it's not taking the main compute load. And your edge devices handle their local, latency-sensitive tasks, checking in with the cloud when needed. Everything flows smoothly across the highway.
But then mode 2 hits degraded network. Someone cuts that fiber optic cable, or there's a massive DDoS attack slowing everything down.
Now, cloud access is limited, slow, or unreliable. The orchestration layer detects this latency.
Automatic.
Yes. It automatically promotes the on-premises infrastructure to become the primary execution surface.
Wow.
The massive cloud model is swapped out for a smaller, highly capable local model running on your sovereign racks. The local model takes over the workloads. Meanwhile, the edge devices realize the network is degraded, so they drop all non-essential communications and handle priority-only tasks completely autonomously.
So the system flinches, but it doesn't break.
Exactly.
And then the worst-case scenario, mode 3 vendor outage. The cloud provider is completely down, a total blackout.
Under a vendor outage, the cloud is totally unreachable. On-premises is now your sole primary brain. The edge runs an autonomous subset of critical functions.
So you're entirely running on your own gear.
Yes. Now, you might not have access to the absolute smartest frontier model anymore. Your local model might be a bit less poetic or a bit slower, but your organization continues to function.
You can still do business.
You can still retrieve evidence, you can still process loans, you can still operate. You have degraded gracefully, not collapsed catastrophically.
Okay, here's my question, though. I want to dig into the mechanics of this.
Dig away.
If our cloud provider has a massive outage and the on-prem warm standby seamlessly takes over making critical decisions, how does the policy engine know what to do if it's disconnected from the mothership? How are we enforcing all that zero-trust identity and governance if the main centralized servers are down?
This is the genius of Berigny's architecture. The centralized control plane mediates this entire process, and it maintained policy-based fallbacks.
Okay.
The control plane isn't just sitting statically in the cloud. It constantly syncs policy state, identity credentials, and routing logic down to the local environments during normal mode.
So the local servers already know the rules.
Exactly. The orchestration layer has the routing rules baked in. It knows that if it cannot reach the cloud, it must route to the local model. But crucially, it only routes to the local model if the local model is cryptographically authorized to handle that specific task and data classification.
So it's not a free-for-all just because the cloud is down?
Not at all. Resilience isn't an IT afterthought here. You don't just figure it out during a panicked Zoom call during an outage. It is an architectural property designed into the workload routing from day one.
So we have this incredibly robust multi-layered system.
Yeah.
But if you think about it, distributing these systems everywhere from a massive cloud server down to an on-prem rack, all the way down to a local edge device on a factory floor, creates a massive security surface area.
It's a huge target.
Every hop between environments, every autonomous agent, every local node is a potential point of attack. How on earth do we protect a surface area that large, especially against threats we might not even fully understand yet?
That is the million-dollar question.
This brings us to a terrifying part of the paper, Zero Trust and the Ticking Clock of Post-Quantum Cryptography.
Security in this highly distributed agentic model relies on two foundational concepts that must work together: zero trust principles and cryptographic agility.
Cryptographic agility.
We have to secure these systems against present threats, like a rogue employee or a phishing attack, but also against a very specific, terrifying future threat known in intelligence circles as harvest now, decrypt later.
Let's start with zero trust because it's a buzzword that gets thrown around constantly by vendors.
It really does.
What does it actually mean in the mechanical context of this specific AI operating model?
Zero trust means exactly what it sounds like. No implicit trust is ever granted based on your network location. In the old days of IT security, we built a digital moat around the corporate castle. If you were sitting at a desk inside the corporate firewall, you were trusted. You could roam the network freely.
Right, you were in.
In a hybrid AI model, the castle walls are completely gone. Your agents are operating in the cloud, on-prem, and at the edge simultaneously. Therefore, every single request, whether it's made by a human logging in or an AI agent asking for a file, must be individually authenticated, authorized against current policy, and logged before access to a resource is granted.
Trust is never assumed.
Trust is never assumed. It is continuously cryptographically proven.
Okay, that makes sense for today's threats. Verify everything, every time. But let's do a deep dive on PQC, post-quantum cryptography.
This is the scary part.
Because reading this section of the paper felt like reading a sci-fi thriller. Berigny notes that agencies like the Australian Signals Directorate and NIST are basically sounding the alarm right now. What exactly is a cryptographically relevant quantum computer, and why are global intelligence agencies so worried about it?
To understand the threat, you have to understand how we secure data today. Almost all internet traffic, identity tokens, evidence objects, and encrypted data are secured using traditional asymmetric cryptography, things like RSA encryption.
Right, the math problems.
Exactly. It relies on mathematical problems, like factoring massive prime numbers. That would take a traditional supercomputer millions of years to solve. A cryptographically relevant quantum computer is a machine that uses quantum mechanics to solve those specific mathematical problems in minutes.
In minutes?
Yes, it will completely break traditional cryptography. Now, we don't have one yet. They're incredibly difficult to build. But the scientific consensus is that they are coming perhaps within the decade.
But if they don't exist yet, why are we panicking about them today? Why do I need to secure my AI evidence architecture against a machine that hasn't been invented?
Because the threat is not just that they will break security then. The threat is harvest now, decrypt later.
Explain the mechanism of that. What does that mean?
It means adversaries, nation-states, advanced persistent hacking groups are actively siphoning and stealing encrypted data today.
Today.
Yes. They hack into a network, they find heavily encrypted databases, and they steal them. They can't read the data right now because it's encrypted with RSA, but they don't care. They are hoarding it.
Just piling it up.
They are storing massive amounts of your encrypted data on their own servers, patiently waiting for the day they possess a working quantum computer. When they do, they will retroactively decrypt everything they harvested years ago.
That is mind-bending. So if my AI system creates an evidence object today containing highly sensitive corporate strategy or personal health information, and it's encrypted with today's math, a hacker can steal it today, hold on to it for 5 years, and read it perfectly in 2031.
Yes, they absolutely can.
We have to secure today's data against tomorrow's computers that are stealing it right now.
Yes. And think about the implications for the AI operating model we just built. Think about all those evidence objects, the OAuth identity tokens passing between layers, the verifiable credentials proving an agent's authority.
They are all vulnerable.
They're all secured by this cryptography. If that cryptography is broken by a quantum computer, the entire chain of trust collapses. You can no longer prove who made a decision, what data was used, or if an agent is actually authorized. The entire 7-layer architecture becomes entirely untrustworthy.
So what is the solution? We can't just invent new quantum-resistant math overnight and instantly update every single server on Earth.
Well, the math is actually being standardized right now by NIST. But the architectural solution is what the paper calls cryptographic agility.
Cryptographic agility.
You have to design your control plane so that cryptography is a replaceable capability. Historically, developers would hard-code a specific encryption algorithm deep into the foundation of their software. It was practically impossible to remove.
Right.
Cryptographic agility means abstracting the crypto library out of the core application logic. You need the ability to swap out old algorithms for new quantum-resistant ones for your verifiable credentials, your agent tokens, your audit trails with a simple configuration update without having to tear down and redesign the entire 7-layer architecture.
It's like building a house where you design the foundation in modular blocks so you can swap out the concrete for a stronger material in 10 years without having to knock down the walls or the roof.
Precisely. If your AI operating model isn't cryptographically agile, you are building a multi-million-dollar system that has a built-in, unavoidable expiration date.
So take a breath, because we have arrived at the summit.
The view is nice from up here.
We have designed this incredibly robust, hybrid, zero-trust, quantum-ready, evidence-based AI operating model. The F1 car is on the track, the telemetry is flawless, the intern has their corporate card monitored perfectly, and the data is locked in a quantum vault.
Everything is in its place.
But looking at this massive, towering structure begs the ultimate question, which brings us to the final major theme of Berigny's paper, the human element and the stewardship gap. Who is actually capable of running this massive machine?
This is the crux of Berigny's entire argument, and it is a stark warning.
A warning.
Technical architecture alone, no matter how elegant, how multi-layered, or how quantum-resistant, cannot produce institutional resilience. An operating model requires operators. And right now, we are facing a massive stewardship gap. The very people needed to run this complex socio-technical system are being systematically marginalized by the tech industry.
Marginalized by what? What is pushing them out?
By the industry's current blinding obsession with hyper-specialization and tooling.
The tooling again?
Organizations are restructuring to hire highly specialized prompt engineers who know everything about coercing a language model to output Shakespearean poetry, but who know absolutely nothing about identity infrastructure, OAuth tokens, or data governance.
Right, they only see one layer.
Or, conversely, they hire rigid security architects who build incredible, impenetrable firewalls, but who never actually look at the semantic accuracy of an AI's output to see if it's hallucinating. Everyone is optimizing within their own tiny silo.
So who do we actually need to run this 7-layer architecture?
We need a revival of what the paper calls T-shaped system thinkers.
T-shaped thinkers.
A T-shaped practitioner has deep vertical expertise in one specific domain, say they are an expert in healthcare compliance or global logistics operations or financial regulations. That's the vertical stem of the T.
Okay.
But they also have broad horizontal fluency across governance, identity, infrastructure, evidence formation, and human-centered design. That's the crossbar of the T. They understand how the whole system connects.
So they see the big picture.
They understand that a change in how a PDF is segmented in Layer 1 dramatically impacts the legal compliance of the output in Layer 5.
So the ultimate irony of the AI revolution is that as the machines get more capable, more autonomous, and more context-aware, well-rounded humans actually become more valuable.
They become essential.
We spent the last 5 years terrified that the machines were going to replace the thinkers. But this paper suggests we actually need a much higher caliber of human thinker to manage the machines.
Think about what AI is actually good at. AI is exceptionally good at processing information. It can synthesize 1 million internal policy documents in a minute.
Right.
What it fundamentally struggles with is significance. It doesn't know what actually matters to the organization. It doesn't understand the unwritten cultural context. The paper highlights the decline of service design as a profession, practitioners who historically orchestrated complex service ecosystems involving humans and machines.
We need them back.
Brigney argues we desperately need them back. Humans provide lived experience, organizational meaning, and legitimacy. The T-shaped steward is the one who can look at a perfectly formatted evidence object and say, yes, this data is technically accurate and the AI followed all the rules, but using this data in this specific context violates our corporate values or fundamentally misunderstands the nuance of this user's intent.
It's the difference between knowing how to read a map and actually knowing the territory.
Exactly.
The AI can read the map perfectly. It calculates the fastest route. But the human steward knows there's a ditch that isn't on the map, or that driving a truck down that specific road will make the neighbors furious.
That's a beautiful way to put it. And this leads to the ultimate conclusion of the paper, which is a powerful call to action for leadership. The operating model described here is not an IT project.
It's not just a software upgrade?
No, it is ultimately a call for organizational redesign. Trustworthy AI is not a compliance overhead. It is not a tax you pay to regulators to keep them off your back. It is a massive, generational competitive advantage.
That makes total sense.
Organizations that understand this will build evidence-centric systems that learn from their mistakes, adapt to degraded environments, and remain resilient in the face of quantum threats. Those that don't will just continuously cycle through disconnected, unmanageable AI pilots, each one creating more liability than the last.
Just crashing golf carts.
Crashing golf carts all over the place. Running this requires managers who can trace a conceptual thread from a high-level policy intent down through cryptographic identity proofing, all the way to the semantic meaning of an evidence object, and back up again.
Okay, let's bring it all together. We have covered an absolute mountain of ground today on this deep dive.
We really have.
We started by shattering the illusion of AI as just a tool, a simple co-pilot you buy off the shelf. We unpacked the 7-layer architecture, highlighting why a cross-cutting control plane is the only thing keeping the golf cart from crashing.
The vital seatbelts.
Exactly. We explored the governance, hinged the evidence object, which turns AI from a mysterious black box into an auditable, living decision intelligence system.
We also looked at how AI agents must be treated as governed, non-human identities, constrained by accountable human sponsors, OAuth delegation, and verifiable credentials. We examined the physical infrastructure, detailing why relying on a centralized cloud is brittle, necessitating a hybrid approach across cloud, on-prem, and edge for true operational failover. And we confronted the ticking clock of post-quantum cryptography, showing why zero trust and cryptographic agility are non-negotiable foundations.
And finally, we realized that all of this brilliant quantum-resistant architecture is completely useless without T-shaped system thinkers to steward it. AI is not a tool you buy, it's a governed, identity-aware, evidence-centric, hybrid execution system. True institutional resilience comes from distributing organizational intelligence intentionally, not just plugging in an API and hoping for the best.
It's been a great discussion.
Before we sign off, I want to leave you, the listener, with a final provocative thought, something to mull over that builds on everything we've discussed today. Think back to that idea of an autonomous AI agent having to retire its memory at the end of its life cycle. We talked about how an agent accumulates massive context over a year of assisting an executive, and how securely destroying that operational memory is a critical security requirement to prevent data leaks. But consider the flip side of that security control.
Okay.
If we are moving toward a world where AI agents act as our continuous proxies, gathering vast amounts of nuanced contextual memory alongside us, well, what happens to the institutional knowledge of your company when an agent is forced to forget?
That is a fascinating point.
When a human employee leaves, they might write a handover document, but the deep context leaves with them. Are we designing organizations where our most capable digital colleagues regularly get total amnesia for the sake of security?
Wow.
And if so, how do we, the human stewards, make up for that lost context? It circles right back to where we started. You can deploy that shiny new AI system in an afternoon. It's fast, it's brilliant, it remembers every...
Until it doesn't.
Right. But navigating the governance, the security, and the sheer human complexity of keeping it trustworthy a year from now, that requires an operating model. That requires a deep dive.
Yeah.
Until next time.